Think about rush hour traffic. Every extra car on the road slows everyone else down, creating a negative externality. Without intervention, too many drivers use the road, leading to overproduction of congestion. Taxes, like tolls, can encourage people to drive less, aligning private costs with the broader social cost. In this video, we'll model how taxes can fix overproduction caused by negative externalities, leading to more efficient outcomes. When solving the negative externality problem, we have three options to try to do this. We could tax the polluting good to get less output. We could directly regulate the pollution levels, or we could create a system of property rights for those with a property right, they're allowed to pollute. And so we can call this the cap and trade system. So I'll start off at this video of going through the way to tax a negative externality to fix that negative externality problem. So over here on the left, we have the market for gasoline. Okay, I've drawn out all the curves that we have to figure out the market outcome and the efficient outcome. So markets will determine that quantity by demand crosses the supply, taking only into account the private marginal cost, not taking into account the external cost. And so our market will give us a quantity, Q market. The efficient outcome, though, is taking into all the costs. So we need to take into account all these external costs. And so the marginal external cost is $2.10 here. And so just say, so for every unit, it causes costs on bystanders of $2.10. And so we shift up the supply curve by the amount of that marginal external cost to get the social marginal cost. And this is the cost to everybody, buyers, sellers, and bystanders, all costs to society. And so the efficient outcome is we want to maximize surplus just with those social marginal costs, comparing it to the demand, and we're going to stop when they're equal at that point there, and we'll get our Q efficient. And so this is why we have an externality problem of markets are going to overproduce, right? Quantity market is greater than quantity efficient. That's bad. That's creating a deadweight loss, again, that we don't like, where our costs are greater than our benefits for those units that are overproduced. So there's our deadweight loss. That's bad. We want to fix this problem. So we can use a tax to do this. So remember, way back when we did the tax module, if we were going to place a tax on the sellers, right, we'd shift up the supply curve. We get like a supply plus tax curve, and that's going to start reducing the quantity. You tax something, you make it more expensive, quantity goes down. And so that's what we want to do here. We want to keep on taxing gasoline until this quantity market is going to get down to equal that quantity efficient, okay? So over here, I have the same quantity market, supply crosses demand. Except now I'm not going to draw in a curve for that social marginal cost. I'm going to draw in a tax. So let's insert a corrective tax of $2.10. So corrective tax $2.10. And we would model that by shifting up the supply curve by that same amount. And so we can do that. And we would call this one supply plus tax. Okay. Now we can find the equilibrium with the tax. Supply plus tax crosses your demand curve. Put a dot there. There's your tax equilibrium. Come down here, and you would get quantity tax. Okay. So the fact that I set our corrective tax, $2.10, exactly equal to that marginal external cost, means we're going to shift our supply curve up the exact amount that the supply curve is shifted up to get the social marginal cost. So this supply plus tax is totally overlaid on that social marginal cost curve. And so what this is going to do is cause private decision makers to actually behave like they are taking into account those marginal external costs, because they have to bear this corrective tax. Okay. And so what that's going to do is it's going to lead private decision makers to reduce their quantity down the Q tax, which is actually equal to this quantity efficient. Okay. And so what we've just done is we say we have internalized those external costs, because the individual decision makers on the suppliers, they have to take into account those taxes when they make their decision. And so in a sense, they have to take into account those external costs now, because the tax equals the external cost. And so this is going to solve that negative externality problem because now the outcome here is quantity tax. Right? Let's find, is there a deadweight loss in this? And so if we're going to get total surplus, our total surplus is marginal social benefit minus marginal social cost, which would be that one. We're going to max out here. Oh, look, quantity tax, right, has maximized our total surplus. We don't want to go any further because that's negative. We have the same total surplus over here. So quantity efficient, quantity tax, same thing. We've solved this negative externality problem with a tax. So a practice problem you might see on an exam might look something like this, where I would ask you, show you a graph like this, where you have a supply curve, a marginal cost curve, and a demand curve. And there's lots of different questions I could ask you about this. First one, what is the size of the negative externality? The size of the negative externality is how far you're going to shift up, right? That vertical distance between the marginal social cost and the supply curve. And so that's going to be here 6 minus 4. And so the size of the negative externality is going to be $2 per unit. Okay. Now, what is the private market going to lead you to? So if you ever see me ask you, what is the private market outcome in presence of a negative externality? We're looking at this graph. What I mean here is like supply crosses demand. That's what I mean by a private market outcome. So supply crosses demand. Private markets will lead you to that outcome right here. And so market output was going to be 12 units. Question 3, what is the socially optimal quantity in presence of a negative externality? In this case, you compare the marginal social cost to the demand curve. And so here, marginal social cost, demand curve, equilibrium right there. For the social, come on down, get 8. That would be our Q efficient. And so we would get an answer of 8 units would be the socially optimal amount. So what is the overproduction in the private market? So that's the market failure. That will be that horizontal distance between the two. So 8 to 12, we have 4 units. So we have 4 units of overproduction that the market's going to give us. And finally, what should the corrective tax be to fix that externality problem? Number 5, you want to set your tax equal to the amount of that marginal external cost, and then you're going to get a supply plus tax curve right on top of your marginal social cost curve, and your quantity tax is going to be equal to your efficient quantity. Right? So again here, if you know what the size of the negative externality is here, $2, you know what the size of the tax is. It is also $2 for your corrective tax to fix that negative externality.